Welcome back. Today we're going to dive into a really interesting topic of physics, friction force in Minecraft. So what exactly is friction? Friction is a force that resists the motion of two objects sliding or rolling against each other. It acts in the opposite direction of the motion, trying to stop or slow down the moving object. There are two types of friction, static and kinetic. Static friction is the force that resists the start of the motion, while kinetic friction happens once the object is already moving. Today we'll focus on calculating kinetic friction, but the concepts are pretty similar for both types. For this experiment, we're going to be finding the friction force of a boat on top of blue ice. In Minecraft, our character is 2 blocks tall, 1 block being 1 meter. So our character is 2 meters tall. The average weight of a 2 meter tall man is 100 kilograms. For our boat, what we're going to be using is bamboo. According to Google, 1 cubic meter of dried bamboo is 300 to 400 kilograms, with it averaging at 400 kilograms. To craft a bamboo boat, 5 bamboo plank blocks are needed. So take that 400 kilograms, multiply by 5, and the weight of the boat is a staggering 2,000 kilograms. We add the weight of our character with the weight of the boat, and in total we have a mass of 2,100 kilograms. Before we start, I have to get the max velocity of the boat. I have a 200 block, or 200 meter, runway to get my velocity to the max. After I pass the first line, I will start a stopwatch and end it when I reach the next line. Between these two lines, there is another 200 block gap. I will do this 3 times to find the average. I then took the average of these 3 times. It takes 3.65 seconds to travel 200 meters. I then take 200 divided into 3.65, and it means I'm going 54.79 meters per second. Now we must find the distance it takes for our boat to slow down at full velocity. I start at the coordinate 0 on the x-axis. I will once again have my 200 meters start, and once I pass this first line, I will take my hand off the keyboard and write down how far I make it past x200 to completely stop. After running this test, it takes me 250 blocks to come to a complete stop. To start, I need to use the kinetic equation. This equation is final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance. I must rearrange these equations for my use. I then substitute. So my acceleration is negative 6.0028 meters per second squared. Now I need to find the force of friction. I use the equation force of friction is equal to mass times acceleration. That gets my force of friction at negative 12,602 newtons. That means the force of friction required to stop a 2,100 kilogram object moving at 54.79 meters per second over a distance of 250 meters is about 12,602 newtons in the opposite direction.
Shadow the Hedgehog from the Sonic series can skate on his air shoes, bounce on springs, and grind on rails to traverse the area. In this video, we will be finding Shadow's impulse when bouncing off of a spring and inertia when grinding through a loop. Since impulse is equal to the change in momentum of an object, to find Shadow's impulse, we just need to find his change in momentum. When Shadow is approaching the spring, he has no vertical velocity. When Shadow touches the spring, he is elevated to a green orb. The height that this orb sits at is roughly around 19 Shadow the Hedgehogs. Since Shadow is 1 meter tall, this means that he is elevated to 19 meters after touching the spring. The time between Shadow touching the spring and reaching the green orb is 0.92 seconds. Dividing the distance traveled by the time taken to travel that distance, Shadow is found to have a velocity of 20.65 meters per second. Multiplying Shadow's mass of 35 kilograms by his velocity gives a momentum of 722.75 kilogram meters per second. The change in momentum can be found by subtracting the second momentum value by the first momentum value. This gives us a change in momentum of 722.75 kilogram meters per second and an impulse of 722.75 newtons.
This is the ultimate power.
To find the inertia of Shadow the Hedgehog when grinding through a loop, we need to find the radius of the loop. The loop's diameter is equal to 5 shadows or 5 meters. Shadow's inertia can be found by multiplying his mass by the square of the radius of the loop. Multiplying his mass of 35 kilograms by the squared radius of 6.25 meters gives us an inertia value of 218.75 newtons.
Do this.
Today we're going to be calculating the sum of forces acting upon a football after it's been kicked by a professional football player in the Retro Bowl. The player kicks the ball with a force of 1500 newtons towards the upper right side of the screen at an angle of 20 degrees. Neglecting air resistance, there's still one thing we're missing, and that would be the force of gravity acting straight downward on the ball. Now we're going to do the work to calculate that. The gravitational constant would be negative 9.81 meters per second squared times the mass of the ball, which is 0.4 kilograms, and giving us the answer. We get 3.92 newtons downward. From that, now that we have the force of gravity acting straight downward on the ball, we must break down the force of the kick into its components, its vertical and horizontal components, so we can then combine the two vertical components that we now have. This formula on our reference table, to find the component, it is A sine and then theta, the angle. A being 1500, sine being the same, and theta being 20 degrees. Now that we've gotten that answer, we must do the same thing with the horizontal value and find the horizontal force straight to the right. Get an answer of 1,409.5 newtons. We subtract the two vertical forces, the 513 vertical force of the kick and the the 3.92 downward force of gravity of the ball. After getting our answer, we must recombine the terms in order to get, we must recombine the vertical and horizontal components to find the sum of forces acting on the ball at this time. And there we get our answer. 1,498.62 newtons. In all, the ball has 1,498.62 newtons acting on it as it was kicked through the air by the player in retro bowl. Here we'll be calculating the circular motion of a biker in Moto X3M video game. A biker circled the circular cage a number of times while making his way through the stunt course. As I clocked it, he completed one full rotation in approximately 1.43 seconds. And the radius I found was 0.03 centimeters. 3 centimeters, 0.03 meters. And as it stands, the necessary component we still need to find is the velocity. And we can't use the regular velocity equation because the biker is moving in a circle. And this displacement would be the same. So for this value, we use a different equation, the centripetal velocity, which would be 2 pi r over time, which would time being the amount of time it took for the biker to complete one full rotation, which in this case is 1.43 seconds. And pi is constant, and r is 0.03 meters. After plugging these values in, I was given a nice answer of 0.1317 meters per second. Oh. The Moto X3M Rider moved at 0.1317 meters per second.
So my segment for the group project was to get an example of an action-reaction from a video game. I chose Mario from the game Super Mario Bros. Wii, in which Mario is jumping by pushing himself off a wall with a force of 250 newtons. Mario's mass is 54 kilograms, and the push lasts for 0.18 seconds, because if you slow down the clip, the impact and dust of the jump doesn't settle until after 0.18 seconds. Using the concept of action-reaction force pairs, I calculated the Italian plumber's change in velocity after the jump. The first thing I did was use the impulse momentum theorem, so that way I could put the force and time together through multiplication. Then when I got my answer of 75 newtons times seconds, I already knew that Mario's mass was 54 kilograms, so I simply had to use division to find the answer of what the change of velocity was, and it was 0.833 meters per second.
One. For the seventh and final scene, as a group we picked Pokemon as the video game genre and momentum as the action sequence. What we needed to do was to convert the given velocity from inches to meters and to seconds. 1 inch converts to 0.0254 meters, so 60 inches times 0.0254 meters is 1.524 meters. And the Pokeball traveled 60 inches in about 1 second. So the velocity is 1.524 meters per second. So to calculate the momentum, we use the formula P equals mv, being 0.15 kilograms times 1.524 meters per second equals 0.229 kilograms.